Hello, we are DronesC and today we will teach you how to choose the components for your first quadcopter that will run you only around $100. Now, to be able to fit within this $100 range, we will be using inexpensive components and considering a simple design. Let's run down the list of items that we will need. First, a frame kit with 4 legs and 2 or 4 plates that tie them together. Second, a battery and accumulator to power everything. Third, a radio receiver and transmitter. Fourth, a little power adapter to provide the necessary amount of volts. Fifth, a flight controller. Sixth, an electronic speed controller. Seventh, 4 propellers. Eighth, 4 unbrushed DC motors. And ninth, any other minute detail that you might need to finish your build. Usually the prices and performance of these items do not vary between different marketplaces, and also the items are usually interchangeable between each other, so it would not matter much which website you use to order them off of, as long as the website is reputable. However, we recommend that you use our aggregator to be able to locate these items easily instead of having to slog through a dozen different websites. The link for the aggregator will be included in the description below. Now, let us discuss the main components. First, the frame. Here we use a cheap copy of a DJI frame wheel F330 or 250. This frame will run you about $16 and will include the optional landing gear, which is basically a steel. If you choose to go with this frame, please get 2 replacement parts. You can also simply buy a quadcopter frame as a part of a larger kit that includes all the other components that you need. However, you might choose to get all the items separately to be able to control every detail of your build. Airframes usually have a number in their name, like 330 or 250, and that number usually refers to the distance diagonally between the motor centers. It may seem that parameters like the distance between the centers of the motor does not affect anything, but even a small addition to the size of your airframe can make your motors more efficient. We will talk about that later. Now let's look at the drive components you will find at each arm of the quadcopter: a brushless DC motor, a propeller, and an electronic speed controller. The brushless DC motor comes in different sizes, and we will talk about how to pick a good size for you later, but first let's focus on other details surrounding how you will get these parts set up. The DC motor has 3 outputs on it that you can connect to the 3 inputs of the speed controller in any order that you like. Often the way that people do it is just to hook up 3 leads and try to see how the motor moves. If the motor moves backwards, you can swap the 2 leads and change the direction that it is spinning in. The speed controller also has 2 leads that connect to the battery for the high current power supply, and a signal wire that is connected to the electronic speed controller. The neat thing is, this connection between the speed controller and the electronic flight controller is how the flight controller is able to instruct each motor to run at a certain power level in order to balance the craft so it can navigate the environment. Now back to the brushless DC motor. Your DC motor has a rating which determines the relationship between the motor's input supplied voltage and its speed. This is oversimplifying things, but you don't need to know more than this at this moment in time. If you get a motor that spins faster, it tends to be more efficient with small propellers, and it is usually better suited for smaller quadcopters. On the flip side, motors that spin slower tend to be more suited for larger propellers, as well as better suited for larger drones. Next, you should look at how the motor rotates, clockwise or counterclockwise. This does not really matter much because you can simply swap any 2 of the 3 inputs of the DC motor leads, but it is still useful to know what your motor is like. Moving on, CW or CCW of your DC motor simply refers to the threading on the nut of your motor if it has one. CW motor has right-hand threads on the propeller nut. CCW motor has left-hand threads. These threads are meant to tighten the nut as the motor spins. You might want to choose your motor depending on whether your nut would tighten by the left spin or the right spin, but it might still be useful to get the universal design where the motor can spin in either direction and the nut is tightened another way. Now let us consider the propellers. In different parts of the world, the propellers are measured differently. However, generally they are specified in terms of inches in diameter and inches of pitch. A simple way to imagine what pitch means is to place your propeller in a semi-rigid medium like clay and see how many inches it moves forward after completing one revolution. For example, here you can see a 8-inch diameter by 3.8-inch pitch propeller. Even though your motor can be either CCW or CW, the rotation of which can be reversed, we think it is important for you to keep in mind that you can not just simply flip a propeller over and expect it to be rotating on the other side. So for your quadcopter, you will need 2 right and 2 left-hand propellers. Let's take a look at the speed controller. For each motor that you install, you will need a speed controller. The main thing to look at in a speed controller is its continuous current rating and its peak current rating. Usually you would want a peak current rating that is quite higher than what you can run in a short amount of time without overheating. The next thing in the speed controller that you would look at is its weight in grams. This is usually not very important. However, for this cheap drone, it would be advisable to go with the more lightweight options. Finally, you need to pay attention to the voltage rating. It is often given in terms of the number of lithium polymer cells that it can handle. We need a voltage rating somewhere around the 2 to 4 battery rating. Some of the speed controllers also have a VEC, which is the battery eliminator circuit that will take the higher voltage from the battery and provide, for example, a 5-volt output. Additionally, a speed controller can also have a little regulator we can use to get 5 volts in output to drive the receiver and a flight controller. Next, let us discuss the batteries. To get longer flight time, you need a drone that can carry more fuel. However, when you are picking your battery, it is important to understand what the specifications on it mean to choose the right battery for your application. The first thing to look in a battery pack is its voltage. That's all for today. Tell us down below in the comments how your first build goes, and we hope that you have a nice day. Thank you.